All right, so today we're going to go over propagation of errors. Last week, we learned how to deal with multiple measurements of an item, multiple measurements of something, where you take multiple measurements of it and you find like the length plus or minus, and then how to find an uncertainty in that length. So let's say that we did that and we came up with 30 plus or minus 5 centimeters. Okay? And let's say that then we had a width here as well. So let's say we measured the width. And we came up with 8 plus or minus 2 centimeters. So this was what we did last week. Basically, you have a list of numbers that you've measured, and you want to know how to find the average and then the uncertainty of those numbers. This week, what we're going to do is we're going to say, well, what if we ended up calculating something with these numbers? If I calculate something with these numbers, then how would I do that? So let's say that we now, with these two measurements, want to find the area of this table. The area of this table. So somebody please unmute and tell me what the formula for a rectangular table is in terms of its length and width.
Length times width.
Yes. Length times width. That's it. All right. There we go. Length times width. Now, considering these numbers up here, what do you think is our best answer for what the area of the table is? I'm just going to calculate the area of the table. How would I do it? Any brave person want to guess?
$30 times 8.
Yes, that too is correct. When you're just calculating the number, you don't worry about the uncertainties. I'm just calculating a number. Here's my number for length. There's my number for width. That's it. 240. And I'll keep my units centimeters squared. There you go. So when you're just calculating the number, you just do that. Now we're going to calculate the sigma. Because we know that this has to have a sigma. There must be an uncertainty here. Because unless you work for the government, if you're not sure about this, and you're not sure about this, when you calculate something with it, you're not going to be sure about the answer. Right? I mean, how can I be sure about this if I'm not sure about this or this? So the question is, how much? How much? Well, it would be nice if it were just multiply those two together. But that's not it. So instead, what we have to do is we have to write down, we have to get a big sigma formula, and it's from the big sigma formula that we write down, that we calculate what sigma area is. So what we have to do is we have to take our equation here and write down a big sigma formula for it. So somebody please screenshot this so we can remember these numbers, because I need to erase this.
I got a screenshot.
Got screenshots? Got screenshots. Good. I'm going to erase it. So to write our big sigma formula, so this is what we have to do. We have to figure out the big sigma formulas. Big sigma formula. Now the big sigma formula, I have to warn you, is not a formula for the sigma. It's a formula that involves a sigma, and we have to algebraically solve it. So we have to make the equation first. what we'll be teaching you today is how to make that equation, and then you'll get a practice in making the equations and then solving those equations. So it primarily, we have to look at the formula that's used to calculate. So in this case, area equals length times width. And we first ask the question, what operation is involved here? What is the operation involved there?
Multiplication.
Multiplication. And so this is going to be product, and we're going to go with the product rule. So that's going to tell us what to do. Product. It's a product for each variable. So the first thing we do is we write down a ratio of sigma A over A squared. Ratio squared. So the left-hand side is ratio squared. And then that's always going to be just this on the left-hand side. On the right-hand side, for each variable, we're going to write down a term, a ratio term, and square it. So somebody tell me what I'm going to write down. So in other words, I'm going to do this same thing, but for L. So what do I write?
Sigma L over L squared.
And then I square it. And then I add, I'm going to add another term for my W. So I'm going to add my W term. So what does my W term look like? Somebody else answer.
Sigma W over W squared.
That's it. Perfect. There you go. Now, we know every number in here except for sigma A, so we can solve for it. This is the easiest way to do it. The first thing you're going to do is plug in the known values on the right-hand side. So we're going to plug all these values in. Plug in. All right. So we plug in and then we solve the right-hand side. So when we plug in the numbers, what was sigma L?
5.
5. Somebody else, what is L?
30.
30. Somebody else, what is sigma W?
2.
2. And then somebody else, what is W?
8.
8. And you can bring this down if you want to, but if you follow my rules, you'll be fine. So we plug in and then we solve the right-hand side. Notice I'm not doing anything over here yet. And I won't until the very end. So then we solve this. In other words, we just plug this in a calculator and solve. So I'll just write calculate, okay? So when you calculate that number, what do you get? Put it in your calculator and you calculate, what do you get?
I got 0.090.
Okay. 0.092, blah, 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 right?
902.
902, blah, blah, blah.
Mhm.
When you're doing these type of calculations, and you get an answer like this, keep the whole thing in your calculator, whatever it is, it's intermediate. Okay? So for all of our intermediate answers, we're going to just keep whatever calculator gives us. So if you can't remember on the calculator, then just write down every daggone decimal point you can. Okay? Now, so we solved the right-hand side, but we're not done yet. We're not done with this yet because we need to get sigma A out of this. So what do I need to do next?
Square root both sides.
I need to square root both sides. So then I take the square root. So somebody take the square root of this side, tell me what you get.
.300462.
0.3004 blah, blah, blah. And now that's sigma A over A. So I just want sigma A. So what do I finally need to do here?
Multiply both sides by A.
Multiply by A. Now, which A are we talking about?
The bottom one?
And no, I mean, what number is A?
240 centimeters squared.
It's 240. It's the calculated number. Okay. So notice in order to find the sigma, you have to calculate what the A is in the first place. So the sigma A here, once we multiply by 240, we multiply by A. Sigma A equals, what'd you get?
72.096.
0.0? Or just 72? It's fine.
096.
0.96, 0.096. Blah, blah, blah. Okay. But we only have to keep the number of decimals that we have in our number. And our number didn't have any decimals in it. So we would just round this off to 72. So one thing about sigmas you want to remember is that the decimals, you're going to keep the number of decimals here as in the calculated number. So here it's just 72. Units of this. Okay, what were the units of the area? So remember we found area equals 240. What were the units of that?
Centimeters squared.
Centimeters squared. Okay. The sigma would have what units?
Centimeters squared.
There you go. There you go. And uncertainty will always have the same units as the thing itself. Okay. So far, so exciting, right? So my product rule, ratio squared, and then for each variable, I have ratio squared plus ratio squared plus dot, dot, dot. If I had more variables, I would just add more terms. For each term, you get added ratio squared. So for each variable. Well, let's make this a bit more general. Now, your book tried to make it general by doing all the ABCs things. Hopefully you didn't read that, and hopefully you're paying attention here. Screenshot, please. Guys, screenshot it?
Yeah.
All right. You kind of like at least one screenshot per group type of thing. So, all right, so I'm going to erase this. And now let's see if we went into something that's more complicated. Let's try something else. Let's say that we have a cylinder here. And we're right over here. And I'm going to write this down. I'm going to measure the diameter of this thing. And I'm going to measure the length of this thing. And my answer has D plus or minus sigma D. So I get this. And I have L plus or minus sigma L. Just to continue on our little example here, let's say this is, I don't know, 5.0 plus or minus 0.1 centimeters. And 8.0 plus or minus 0.2 centimeters. There we go. Let's just use these numbers. And then that way, we can actually calculate a number together and you'll get more practice doing that. Because I'm learning that as we go over Zoom, it's more important that you do more examples. I learned that about 3 hours ago when I was teaching the other lab and everybody was lost. So there you go. All right, so here we go. So now what we want to do is we want to, first of all, we need to get the big sigma formula here. Well, actually, yeah, big sigma formula. But the first thing we need is the formula for the volume of a cylinder in terms of the diameter. Now you're used to calculating the volume in terms of the radius. So the volume here would be the area of the circle multiplied by the length. So does anybody know what the formula is for the area of a circle in terms of its radius? What would you say?
Pi r squared.
Huh? No, that's wrong. Pi r round, cornbread r squared. Okay, that was bad. But that's right, it would be pi r squared. Here we have the diameter, so we get a factor of 4. So pi over 4 multiplied by d squared multiplied by L. So now we're going to use our product rule, because notice these things are multiplied. They're multiplied, so we use the product rule. So I'm going to start here, and somebody tell me, what do I write down on the left side to get my big sigma formula? What do I write down over here?
Sigma v over v.
v over v squared.
Sigma v over v, and what do we do with it?
Square it.
Square. Okay. So you did the whole left side of the equation. There it is. All right, now we need each variable here. In a product, this coefficient doesn't matter. It doesn't add anything to the uncertainty, because there is no uncertainty in pi over 4. It's just pi over 4. It's just a number. So we don't need to worry about that. We only need to worry about the variables. So I have a variable d here, so I want to write down a term for d. So somebody tell me what I write down for d. We're using the same rule we did before. We just want to write this for d. What do I write?
Sigma d over d squared.
And then what do I do with it?
You square the whole thing.
I square it. There you go. And then I'm going to do what operation for my next term? I do what?
Addition.
Addition. I'm always adding another term. I have another variable here, L. So I need to do that too. So what do I write down?
Sigma L
Sigma
over
over L.
L.
Squared.
And then I do what?
Square it.
Square it. Okay, there's our product rule. That's what you do for the product rule. For each variable, you write down ratio squared, and then ratio squared. Now in this case, though, we're not quite done. Why aren't we quite done?
Because isn't it d squared? On
Because we're not just multiplying by d. We're multiplying by d squared. In other words, we're using the d twice. We're using the d twice. And so what we do to take care of that is we pull the exponent, which tells us the number of times that we do this. We pull the exponent down here in front. And then what do we do with it?
Turn it into your coefficient.
What do I do with the coefficient when I pull down front?
We square it.
I square it. Just like everything else you're gonna, when you pull down here, you square everything else. You always end up squaring whatever you put down there. All right, so then we can calculate this number. So let's go ahead and do that. What I'm gonna do is I'm gonna plug everything into the right-hand side. So I've got 2 squared here, multiplied by 0.1 over 5 plus 0.2 over 8. Then I'm going to solve this right-hand side algebraically. Now, I've not done this as an example first for this yet. So what do I do? So somebody needs to tell me what to get out of this, and I'm going to have some confirmations. And by the way, you cannot add the terms and then square it. You have to square the terms and then add together.
We got a 0.00222.
Okay, you got 0.00222,
Yeah, 2225.
2225. blah, blah, blah. Do I have a confirmation on this?
Yes. Yeah, I got the same thing.
Okay. If you didn't get that, figure out how to manipulate your calculator. That's calculator manipulation. All right, so now what do we need to do with this number? So we solve the right-hand side, right? We calculate, then we do what?
We square root it.
We square root it. So we square root this number. That no longer will equal what's above what we square root it. Let me rewrite this down here, sigma d over b now. So when you take the square root, what you get?
Zero 0.0471.
Okay.
Dot, dot, dot.
And now we have to multiply by the v, but we didn't calculate the v yet, so we have to calculate the v. Let's calculate the v. Okay, so let's plug in and calculate the v. In fact, you'd probably do that before you calculated the other thing. So this is pi over 4 times 5 squared, multiplied by 8. Do not put this as 50 pi, even though that is what it is. Actually, get a number for me.
I got 157.0796.
Okay, sounds very reasonable. 157 point blah blah blah, which is 157 is fine. And then the units of this are it's a volume,
Centimeter squared.
not volume.
To the third.
Cubed.
There we go. Centimeter cubed. Okay. So now to find sigma v, we're going to take this and multiply by v. So we have to multiply by v. Okay. So remember, the rule is calculate, square root, and then multiply by v. Okay. So now this is sigma v here would be equal to what?
7.409.
7.49. Okay. But if we look up there, that doesn't have any decimals in the number, so we would only keep the 7 when we wrote an overall answer. Okay. The units of this are going to be the same as the units of the part. So there we are.
So whenever we do the lab, we just write 7. We don't have to write 7 points.
I asked you to write the whole thing first, and then at the end write 7, round it off.
Oh, okay.
Yeah. Very end. I asked you to keep so many significant figures in each of the answers, because all you're turning in are answers today. So, you know what I mean? If you round off too much, then I won't be able to figure out whether the what you might have done wrong in the calculation.
Yeah,
So
yeah.
you're keeping your work on separate pieces of paper. All right, so now, okay, so that's this one. Now there's one more thing. Sometimes the formula isn't very nice. Okay, so here's this. Sometimes the formula isn't very nice. So screenshot this, by the way. So screenshot this example here. What do we do when the formula is a big messy mess? All right, so I don't want to actually do this as a full example, even though you can look up the rest of the full example in your thing here. So if I look, I'm going to be looking at your write-up for this lab, Propagation of Errors. And I'm going to just be looking at this one formula they give you for, there it is, Kepler's Law. So Kepler Law, example 2.2. Let me share my screen. All right, so here we have this formula. It looks like this. Okay, so that t equals 4, the square root of 4 pi squared ma cubed over k. All right. So I'm going to write this on the board here. Okay, so we have this. T equals the square root of 4 pi squared ma cubed over k. Yuck, right? So how would we write a big sigma t formula for this, the sigma t formula? Well, the sigma t formula for this, well, we don't like the way it's written. When I'm just calculating the period, the t for any of these questions, I would just use this formula. But to find the big sigma formula, we want to rewrite this as a product with exponents. So to get the big sigma formula, we're going to write this as a product with exponents. Okay. Well, there's a square root there. What do I do with that? What is that? I need to put that in terms of exponents.
It's a half power.
So it's a half power. So I need to rewrite this t with half power. So I'm rewriting this. So 4 pi squared m a cubed over k, all to the 1/2 power. Okay. So what we'd have to do is you have to put each term here. So each term gets a 1/2. So it's 4 to the 1/2, pi squared to the 1/2, m to the 1/2, and a cubed to the 1/2, divided by k to the 1/2. Now there's one. Now we have to kind of solve for this, or kind of fix it up a little bit. Let's see if I write over here, will it work? Yes. All right. So 4 to the 1/2. That's square root of 4. What's that?
2.
2. Okay. Pi squared to the 1/2 is what?
Pi.
Pi. Okay. M to the 1/2. Well, that's just m to the 1/2. A cubed to the 1/2 is what?
3/2.
No, 8 cubed to the 1/2. Exponent of an exponent. What do?
You multiply
So what? A to the what?
3/2.
3 over
2.
2. Divided by k to the 1/2. Now, there's one more thing we can do with this to make it even nicer. However, it doesn't actually matter, and I'll talk about that in a moment. All right. So now we're going to use this form right here to write our big sigma formula. Okay. This form right here to write our big sigma formula. So I go sigma t over t squared, right? We're going to do product group. Let's look at the variable m. So what term do I write down for m? Don't worry about the exponents yet.
Sigma m over m squared.
Yeah, sigma m over m. This is all you're doing. And then we're going to add another term for a. So what do I do?
Sigma a over a squared.
Sigma a over a squared. Now, whether it's a product or a quotient, I'm still going to add the next term. So I add the next term. And what's the next term?
sigma k over k squared.
Sigma k over k squared. Okay, so whether it's a product or a quotient, I add that term right onto it. Doesn't matter whether I'm multiplying or dividing. I add that term. And now I take the exponents and take care of them. So what exponent do I put in front of my sigma m term?
1/2.
1/2 and square it. Okay. So here it's 1/2 squared. So I bring down that exponent. I bring down this exponent and square it. What's the exponent here?
3/2.
3/2. And I do what with that?
Square it.
Square it. And here, what's the exponent here?
1/2.
1/2. And I do what with that?
Square it.
I square it. Okay. So when it tells you to write the equation in that form that it says, you're just going to write it out as a product. Now, the reason why the quotient works instead of the product, if I were to write that k as a factor instead of a quotient, what would I have to do to the exponent here? If I were to take this k, right, and write it up here like this, what exponent would I need to put on it?
Negative 1/2.
Negative 1/2.
Mhm.
But notice, I would just end up squaring the negative 1/2.
Makes sense.
See what? So it doesn't matter. So multiplication and division, it's the same thing. In fact, it might be less confusing if you went ahead and leave it at division, keep your positive exponent. But you just have to remember, you're adding terms. You're always adding. You're always adding terms. So now you are ready for the product rule. Okay. Let's take a look at the other rule that we will have sometimes, and that's the addition rule. And it also, by the way, addition or subtraction. So let's say that I wanted to know what Q was, okay? And Q is L minus 2W. L minus 2W. Well, now we're using addition. And remember, our L from before was, what was it, 30 plus or minus 5. And our W was 8 plus or minus 2, like that.
Yeah, that's right.
Okay. All right, so I want L minus 2W. I don't know why I want that. I just want that, okay? I just want that. All right. So let's calculate what Q is first. So Q would be 30 minus what, 16? Sorry, just plug in the numbers. 30 minus 2 times 8. What do we get? 14?
14.
Yeah, okay, 14. And now we want to find sigma Q. Well, you still are going to write terms, but for addition rule, the addition rule, it's a little different. Instead of writing ratio, you just write sigma squared. So for every variable, I'm going to write a sigma squared, not a ratio now, but a sigma. So addition rule, it's sigma. Sigma squared terms. For the product rule, product, it was sigma over the number. Okay, it was ratio squared. That's the difference. We're still adding terms. We still have terms on the left and right side. The only difference is that we're going to write sigma for this. And if it were the product, I'd write a ratio. So here, instead of writing sigma q over q, I would write just sigma q squared. Sigma q squared. Let me change colors so you can see it. Okay, so sigma q squared. Okay, now, the first thing I have right there, the next variable is the L. So what do I do with the L? What do I write for L over here? What do I write?
Sigma L squared.
Sigma L squared. And then I'm going to add the W is what? What would I
Sigma
write over here?
W squared.
Sigma W squared. That's it. In other words, for each variable, I just write an addition. That's it. Now, in addition, the coefficient takes the place of the exponent for multiplication. So the coefficients for addition act the same as the exponents do for a product. So what's the coefficient of this one?
1,
1. And the coefficient for this one?
2.
2. Notice if we're -2, it would end up being the same thing because you take the 2 and what do you do with it? Square it. Just like we would take the 1 and square it. Whatever you put into this formula, you end up squaring it. So whether you're adding or subtracting, it doesn't matter because you would end up squaring the negative coefficient. And there you go. Let's actually calculate this thing. Okay, sigma q squared. This one's a little easier to solve for because we don't have to. There's one less step here. So sigma L is 5 plus 2 squared times 2 squared. Wow. Okay. So we calculate this. This is 25, and that's 16. 25 and 16 are what? $25.
41.
41. Okay. And now what do we need to do with this? Whoops, I'm sorry. What do we need to do with this now? Only one step, not two. What do we need?
Square
to
root.
do? Square root. So take the square root, and we found our sigma q. What's the square root of 41?
.40.
6 point something?
6.40.
All right,
Three.
6.4.
Yeah.
And the unit for this is going to be the unit for this. I'm just adding links together or subtracting them. So what's the unit of this up here? Would be what? Centimeters plus more centimeters. What is it?
Centimeters.
It's in centimeters. And so my sigma is going to have a unit of
Centimeters.
centimeters.
We then put it and just write it as 6 because of sig
Huh?
fig. Would we just write it as 6 because of sig figs?
Oh, I would. Well, in this case, I'm not worried about sig figs for this. For these exercises, we kind of you'll see the way we do the exercises. So let me show you that. I'm going to be sending you off in your groups. Okay. So I need you guys when you're calculating these things, when you're showing each other how to calculate them. All right. I need you to be screen sharing or use your camera and a piece of paper. Don't be shy about this because when I come around to help you, I need to see what you did so I can point out your mistakes. It's really hard for me if I don't see your mistakes. And if I just write something on a board and then you write it down, I have no idea whether you actually understand it or not. I'm trying to encourage you, but it's hard to tell. So you guys are going to be sent off to do the exercise. So to the people watching the recording, have a nice day.